Okay, example 4. Find the measure of angle A in the triangle shown. And if I start taking inventory here, I've got my right angle here. I know a side, and I know a side. So if that's angle A, I'm going to call this angle B. I'm going to call this angle C. If this is angle B, if I go across the triangle, this is side B. That's typically how math books at this level arrange things. First step, I see it's two sides given, so again I'm given two sides technique. That's not working. There it goes. Given two sides technique, so I'm going to start with the Pythagorean theorem to find the third side. The missing side, you'll notice, is a leg. So I know that 8 squared plus b squared is equal to 17 squared. Leg squared plus leg squared equals hypotenuse squared. 8 squared equals 64. 17 squared is 289. Subtract 64 to get b squared by itself, so b squared equals 225. And the square root of 225 is 15. Exactly 15. So b is exactly 15 centimeters. So in the last problem we had an approximate value for the hypotenuse. Now we have an exact value for the side because it just happened to come out exactly right. That happens sometimes too. Okay, so at this point, step 2, pick an acute angle you want to know. Let's say I want to find b this time. Suppose I want to find b. Which side is opposite b? B is up here. Where's the opposite? Down here, 15, right? Called it little b also. So b is opposite side b. So 15 centimeters opposite. Which side's hypotenuse? 17 is the hypotenuse because this is opposite the right angle. And once we have opposite and hypotenuse identified, the third side has to be the adjacent side. Now in this case, all three numbers are exactly right, so I could use sine or cosine or tangent. I'm going to get the exact same result no matter what I use. So in step 3, where it says determine either the sine or the cosine or the tangent, SOHCAHTOA, you get to pick. It doesn't matter. So Dominic, what do you want to pick? Sine, cosine, or tangent? Sine. All right, Dominic's almost sine. So if I write a sine expression for this triangle with what I know, sine of b, because that's the angle we're working with, sine of b equals opposite, which is 15, over hypotenuse, which is 17. Again, that's the exact thing that Dominic wanted me to use, so I'm using it. But again, it's always sine of an angle equals the correct ratio of sides. Right? And since I do not know the angle, to find the angle I have to do the inverse sine of 15 over 17. So I'm going to take my calculator, hit the second sine of 15 over 17. 61.93. Now real quick, what is the tangent of b? If I was trying to do tangent of b, what does it equal? 15 over 8, right? If I did inverse tangent 15 over 8, same exact answer. Because that's what b equals. What's the cosine of b? Cosine of b would be 8 over 17. So if I do inverse cosine of 8 over 17, I get the same answer because that's what b equals. It doesn't matter which trig function you go with. You do it correctly, write the correct ratio here, and then do the correct inverse trig function of the correct number, you're going to get the correct answer. That's what b equals, and there's no way to avoid that. So where it says determine either sine, cosine, or tangent, that's what, it doesn't matter which one you pick. And then step 5, subtract from 180 to find the other angle. So angle A is going to equal 180 minus this plus 61.93. So that's 151.93. So A is going to equal 28.07 degrees. So regardless of direction in your homework, I want you to find all the missing pieces. If you know one side, one angle, there's one angle and one side, or two sides to find. If you know two sides, there's one side and two angles to find. So altogether, 3 answers for every problem. Find me all the missing parts of the right triangles using one of these 2 techniques based on your inventory of what you're given.